Yes, you made it to 3.3, solving square root equations. So I want to do a little quick review on how do we solve equation with square root and review some domain and range. So students will be able to solve equation that has a square root. So the first thing and the utmost important thing for today's lesson is what's the inverse of a square root? So if I have the square root of x, the inverse of that would actually be x squared. So when I'm taking the square root, the inverse will be x squared. So the key is when we're solving equations like this, our key is to isolate the square root expression first before squaring both sides. So if you look at A, super easy. I have square root of x is equal to 7. So there's nothing, there's just a square root of x by itself, and we said the inverse of a square root is square. So what I'm going to do is take the square. Actually, let me rewrite this so I have more space and it doesn't look too confusing. So I have the square root of x is equal to 7. So what I want to do is take the square root of the square of both sides. The square root and the square cancels, and I'm left with x is equal to 49. And that's it. Now, if we look at B, it says the square root of x minus 3 is equal to 5. So again, what I want to do is take the square of both sides. Let's see if I can make it fit. Perfect. The square root and the square cancels. I'm left with x minus 3 is equal to 5 squared is 25. But now I'm not finished. I want x by itself, so I'm going to add 3 to both sides. This is canceled. X is equal to 28. There you go. What about one more here? So we had a simple one-step, two-step. Now let's look at this. First thing, square both sides. The square root and the square cancels. 2x minus 1 is equal to 4 squared is 16. Add 1 to both sides because I want to get x by itself. 2x is equal to 17. And how do you get x by itself? Divide both sides by 2. X is equal to 17 over 2. And that's my final answer. Good job, guys. Now, for D, what we need to work on first. So, whenever we have something like this, 3 square root of x minus 4 is equal to 20, I need to get rid of anything that's next to the square root of x. So in this case, minus 4. So I need to get rid of minus 4 first. So in this case, it'll be plus 4. No, yes, plus 4 on both sides because we're doing the inverse. This is cancel. I'm left with 3 square root of x is equal to 24. So just like we would say when you have something as 3x, we said this operation is always a multiplication. Same goes for something that I have a square root. So this is multiplying. When I divide by 3 on both sides, it cancels this off. Once it cancels that off, let's get some more space. I am left with the square root of x is equal to 24 divided by 3 is 8. And now this is where I just go ahead, take the square root of both sides. Square root and square cancel. X is equal to 64. So let's look at E. 2 square root of x plus 5 plus 7 is equal to 17. So again, I want to get rid of anything that's next to my radical sign. So I'm going to minus 7 on both sides. This is cancel. 2 square root of x plus 5 is equal to 6. Then I want to get rid of this 2 because I can't get rid of the 5. It's still under the radical sign. So divide both sides by 2. This is cancel. And I'm left with square root of x plus 5 is equal to 3. Now is when I square these. Square root and square cancels. I'm left with x plus 5 is equal to 9. Minus 5 on both sides. X is equal to 4, and that's my answer. So we have one more to go. Same goes, add 4 to both sides, cancels that out. 5 square root of 3x minus 2 equals to 40. And now I want to divide by 5 on both sides. And then I'm left with 3x minus 2. 40 divided by 5 is 8. Now that you got the square root by itself, all I'm going to do is square both sides, just like we did in those examples. Square root and the square cancels off. 3x minus 2. 8 squared is 64. If you're not sure, check on the calculator. Add 2 on both sides. Remember, I'm taking it over. This is cancel. 3x is equal to 66. My last and final step to get x by itself is divide by 3. This is cancel. And I have x is equal to 30. Nope. X is equal to 22. That's my final answer. Okay? So, moving right along, let's see what we have next. Alright, so example number 2, this is how it shows up on the regions. Which of the following is the solution to 3 radical x divided by 2 equals 15? So, again, what do I need to get rid of first? I need to get rid of the 3. Remember, that's multiplying. So, I'm going to divide everything by 3. Then these 3's are cancelled. Square root of x divided by 2 is equal to 5. Now, how do I get rid of the square root? Perfect. Take the square. This is cancel. You're left with x over 2. 5 squared we know is 25. Then to get x by itself, I need to get rid of this 2. This is in the denominator, means it's dividing, so I do the inverse, meaning multiply both by 2. X is equal to 50, which is choice number 3. Alrighty, we have some square root functions. Consider the 2 functions below. F of x is equal to the square root of x, and g of x is equal to the square root of x plus 3 minus 2. So I want you to graph those functions. So grab your calculator. I'm going to wait for you, and we're going to graph square root of x and square root of x plus 3 minus 2. Go ahead, get your calculator. I'll wait. Alrighty, so now you got your calculator. Let's go ahead and graph the square root of x, which you should get a graph that looks like this. And then you want to graph square root of x plus 3, and be careful, this minus 2 is outside of that square root sign. You should get a graph that looks something like this, okay? Pay attention onto how I enter this on the calculator. Then I want you to sketch it. So we're going to review now, state the domain and the range. So let's look at this f function. I know that domain is my x value and range is my y value. So I'm going to look at my x-axis. And if you look at this graph, it actually starts like right in the middle of the in the origin. So I want to know what's the domain. Notice that this line keeps going and going and going and going. We know that's infinity. So my domain, all I'm going to write is that my domain is x such that x is greater than or equal to 0. Okay? And then my range I know is my y value. And my y value on this actually is at the same exact place right here. So my range I'm going to write is as y such that y is greater than or equal to 0. Because all my y value is on the, it's going up. As this increases and go up, my y is going to go up. On the other hand, for the g of x function, what's my domain? So my domain is my x again, and my range is my y. So my domain, I know it's x, such that x, let's see, so my domain is x. This graph actually ends right here, and if I go up, it's at this point. So this is -1, -2, -3, such that x is greater than or equal to -3. Greater than or equal meaning it's all of these values and it goes on forever. Same goes with my range. The graph stops at this point, and because my range is my y, I'm going to go across this way, and this is actually -1, -2. So my range is going to be y such that y is greater than or equal to -2. And again, it's greater than because all my values for y are increasing after that. So please be extra careful when you enter this. If you're having an issue, please see me or Miss Ewing, okay? Now let's look at a few more examples. Which of the following word represents this graph? So all we're going to do is on our calculator, let me get my calculator. So I got my calculator, I'm ready to go. The question says, which of the following equation would represent a graph that looks like this? So what I'm going to do, I'm going to go to the home, I'm going to go to graph, and I'm going to enter the first one. Negative square root of x plus 4, enter. So I want to look at the graph. I see that it starts at -1, 2, 3, -4, and it kind of goes down. So let's see at this. Whoa, look at that, side by side. Same exact thing. 1, 2, 3, 4, and it goes down. It intersects at 2. This intersects at 2. So there you go. You have it. Your answer is actually choice number 1. How easy was that? 2 points on the regions. 2 points on the regions. There you go. So for exercise 5, it says determine the domain of each of the following square root functions and express your answer in integral notation. So where did it go? Here we are. First thing, integral notation means I have, let's say, -infinity to +infinity. That's integral notation. So the first thing I want to do is set this up. So square root of x plus 2 has to be greater than or equal to 0. There's no way it can be a negative number, because if I put the square root of a negative number in your calculator, let's just say square root of -12, you will get like error or no real result, something like that. So the square root of a negative number does not exist. So that's why I always set this equal, greater than or equal to 0. Now that I have this, what I'm going to do is get rid of the square root by squaring both sides. This gives you x plus 2 is greater than or equal to 0, minus 2 on both sides. This is cancel. X is greater than or equal to -2. But I'm not finished because it says write your answer in interval notation. So interval notation would be my bracket, because it can be equal, -2, comma, and this goes on to infinity with a parentheses like that. Okay? Same thing goes. The only thing is you got to know how to set these up. 3x minus 2 greater than or equal to 0. Get rid of the square root, just like we talked about previously, squaring both sides. These are cancel. 3x minus 2 is greater than or equal to 0. Add 2 to both sides. Perfect. 3x is greater than or equal to 2. And then I want x by itself. What would I do? Divide by 3. Cancel. X is greater than or equal to 2 over 3. And remember, my integral notation would be 2 over 3, comma, infinity. And then our last one. Set it up correctly. 8 minus 2x is greater than or equal to 0. Take the square of both sides. 8 minus 2x is greater than or equal to 0. Minus 8 on both sides. This is cancel. Minus 2x is greater than or equal to negative 8. Remember, you have to bring this entire thing down, okay? Now, I want x by itself. What am I going to do? I am going to divide by an... Why is my division sign all the way at the bottom? What am I going to do? Divide by a negative 2. Divide by a negative 2. My negative 2 cancel. And remember, with inequalities, a little special. With inequalities, what happened when you divide by a negative number? You switch the inequality sign. So this becomes x is less than or equal to positive 4. But I'm not finished. My integral notation. So integral notation would be, yep, negative infinity to positive 4 included. Okay, just pay extra attention here. You know, I change the sign from here to here. Change sign because I divide by a negative number. Okay? And that's something you should remember from Algebra 1. Now that we did our practice problems, you're on your own. Good luck.